Hello students. Now we discuss equivalent protons. Equivalent protons means similar or same chemical environment protons are called equivalent protons. Similar or same chemical environment protons are called equivalent protons. For example, we taking one example, methane. The structure of methane is this. Here four hydrogens are four hydrogens, while on the other hand four protons. Each hydrogen means hydrogen means proton. Hydrogen nothing but proton. So four protons are same chemical environment. Therefore, these protons are equivalent protons. Another we taking example, neopentane. 5 carbons. Here total 5 carbons are there. So 5 carbons like this structure calling neopentane. In neopentane 4 methyl groups. 4 methyl groups are attached to single carbon. So 4 methyl protons are in same chemical environment. Therefore, they are equivalent protons. I am taking another example. For example, CH3 protons. These three protons are same chemical environment, means these three hydrogens attached to single carbon. So these three hydrogens are chemically equivalent, same chemical environments. And I am taking another example, CH3 attached to CH3. Here these three CH3 attached to CH3, this CH3 attached to CH3. So finally the 6 protons are chemically equivalent, but one CH3, one CH2. Here these two hydrogens are same, but compared to CH2, this CH3 is connectivity different. So that's why these two are non-equivalent set of protons. Means next another example, ethane. In ethane 6 protons are same chemical environment, therefore equivalent. I am taking another example. Here CH3 attached to CH2. Here also CH3 attached to CH2. So this CH3 same chemical environment, but CH2 is different. So in propane 2 methyl protons are in same chemical environment, therefore they are equivalent protons. Methyl protons 6 protons are chemically equivalent, so they are equivalent protons. Next, non-equivalent protons. Different chemical environment protons are called different chemical environment protons are called non-equivalent protons. For example, ethyl chloride, CH3CH2Cl. What is this? Ethyl chloride. In ethyl chloride, CH2 CH3 protons are in different chemical environment. Means here CH2 directly attached to chlorine, but CH3 is not. So CH2 protons are different, CH3 protons are different chemical environment. That's why they are non-equivalent protons. Another example, ethyl acetate. this part is ethyl, this part is acetate. So totally ethyl acetate, ethyl acetate. In ethyl acetate, CH3, another CH3, CH2. Here, this CH3 will attach to CH2, but here, this CH3 attached to CH2, this CH3 will directly attach to C double bond O. That is the difference. So, these two CH3s are different chemical environments. That's why they are non-equivalent. And also one CH2 is present. So totally 3 CH3, 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 CH2. 3 different chemical environment protons are present. So finally 3 sets of non-equivalent sets are present. So this is the non-equivalent definition. And another example, acetaldehyde. What is this? Acetaldehyde. In acetaldehyde, one CH3 protons are present, one aldehyde proton. This is the aldehyde proton. One aldehyde protons are present. In acetaldehyde, CH3H protons are in different chemical environment. Therefore, they are non-equivalent protons. We are taking another example, acetic acids. Acetic acid. Here one CH3 is there and one hydrogen is there. So totally 2 different type of protons are present. Therefore 2 different chemically non-equivalent protons are there. Hello students, we are going to discuss one important question. Describe the HNMR spectrum of ethyl bromide. Ethyl bromide, what is the formula of ethyl bromide? CH3 CH2 Br. CH3 CH2 Br is called ethyl bromide. Here 2 different type of hydrogens are there. So the compound has 2 sets of non-equivalent protons, and hence HNMR spectrum of the compound shows 2 signals. One, we discuss detail of 2 signals. The signal of CH3 protons appears at delta 1.6 and the peak is split into triplet due to coupling with adjacent CH2 group. Here, these CH3 protons will split into triplet. Why? Because the adjacent carbons, these 3 protons coupling with these CH2 protons. These 2 protons are there. So by n plus 1 rule, n is neighboring protons. Neighboring protons are 2 plus 1, 3. Totally, so triplet. So the signal of CH3 protons appears 1.6 and the peak is split into triplet due to coupling with adjacent CH2 groups. Now, second signal. Now we discuss second signal. The signal of CH2 protons appears at delta 3.3 and peak is split into quartet due to coupling with adjacent CH3 protons. Here we discuss CH2. Here CH2 protons are coupled with CH3 protons. So CH3 protons are 3. By n plus 1 rule, n is equal to number of neighboring protons, 3 plus 1, therefore 4. Therefore quartet. The signal of CH2 protons appears delta 3.3 and peak is split into quartet due to coupling with adjacent CH3 group. Note: in ethyl bromide, CH2 protons are highly deshielded due to CH2 protons are attached to more electronegative bromine atom. Here, CH2 protons are directly attached to more electronegative bromine atom. That's why here bromine is more electronegative atom. CH2 attached to more electronegative atom. So that's why CH2 protons are more deshielded. So that's why the signal is appear more downfield, down on the downfield. Now we discuss the signals of ethyl bromide are as follows. The signals of ethyl bromides are as follows. Ethyl bromide, methyl protons are at delta 1.6, CH2 protons are at delta 3.3. CH2 protons appears quartet, CH3 protons appears split into triplet. So that's why here CH3 CH2 Br. CH2 protons are more deshielded, so the signal appears on left side. CH3 protons are appear triplet, means 3 signals. CH2 protons are appears quartet. Quartet means 4 signals. And a ratio of 1:3:3:1. Here this peak is reference peak, TMS peak, trimethyl silane peak. We take one important reference compound in proton NMR spectrum. Very important reference compound is TMS. This is the HNMR. This is the HNMR spectrum of ethyl bromide. Hello students. Now we are discussing very important question. The question is, describe the HNMR spectrum of acetaldehyde. Acetaldehyde, the structure of acetaldehyde, the formula of acetaldehyde is CH3 C double bond OH. CH3 C double bond OH. Here two different type of hydrogens are there. Hydrogen nothing but protons. Two different type of protons are there. So we are calling two non-equivalent protons. The compound has two sets of non-equivalent protons and hence HNMR spectrum of the compound shows two signals. The compound has two sets of non-equivalent protons and hence HNMR spectrum of the compound shows two signals. The signal of CH3 protons appears at delta 2.2 and the peak is split into doublet due to coupling with adjacent C double bond OH group. Second signal. The signal of C double bond H protons appears at delta 9.8 and peak is split into quartet due to coupling with adjacent CH3 group. Note, important note, acetaldehyde protons nothing but this is the aldehyde functional group, this is the aldehydic proton. Aldehydic proton are highly deshielded due to hydrogen is bonded to CO carbonyl group and signal appear far downfield. Far downfield means left side on the HNMR spectrum. Here students, here CH3 C double bond OH. Here hydrogen is attached to C double bond O. That's why here more energy is required to flip this hydrogen. So that's why it is more de-shielded proton. Here always CH3 protons are less chemical shift values.